Okay, lesson 106, two-step equations. So what this means is we're going to have a variable and we're going to try to figure out what it means. So example 1 says 3n minus 1 equals 20. So I can think about that, and if I think about 3n and I subtract 1, it equals 20, then I know is that 3n equals 21, right? Because 21 minus 1 is 20. Okay, so I can say 3n equals 21. And now remember how I can do this where I want to disconnect whatever's attached to the n. So let's divide both sides by 3. That turns into a 1. N equals 21 divided by 3. N equals 7. Okay, that involves some thinking ahead of time. I prefer example 2. Oops, I'll give you guys some extra problems, where they actually write it all out using inverse operations. Ooh, inverse operations. Inverse just means opposite. So we're going to say again, 3n minus 1 equals 20. Okay, remember my goal is to isolate the variable, to get n by itself. So I'm going to disconnect everything attached to the n. I'm going to do the extra stuff that's not connected directly to the n by multiplication or division first. So I'm going to do that 1 first. I'm going to add 1 to both sides. Remember, I can do whatever I want to both sides of the equation as long as it's still equal. So what's 20 plus 1? 21. What's negative 1 plus positive 1? 0. So I can just leave that blank. So I get the same thing here, this way and this way. But if it gets more complicated, I'm showing my work, right? So again, I'm going to now divide both sides by 3, and I get n equals 7, right? Same idea. The book writes it out, 3n minus 1 plus 1 equals 20 plus 1, that way. I prefer up and down. I don't know why. You can do it either way. Let's go back to our there's no such thing as subtraction. Like that. So you know that's 0. So 3n plus 0 equals, so it was 20 plus 1, wasn't it? Something looked wrong. Like that. So I can do it that way too. Let's practice with one more. These aren't hard. Just remember to get rid of the addition and subtraction first, and then try to get rid of the multiplication and division. When they said inverse operations, what's the inverse of adding? Subtracting. What's the inverse of subtracting? Adding. What's the inverse of multiplication? Division, and vice versa. Okay, so 4x plus 7 equals 31. Remember, you can write it out horizontally or vertically. I like vertically. I'm going to do the inverse of adding 7. So I'm going to subtract 7 from both sides of the equal sign, right? So I'm just going to bring that down. What's 31 minus 7? 24. What's positive 7 plus negative 7? 0. So I can either add that in or I can leave it blank. And I don't have anything to do there, so I just bring it down. 4x equals 24. Now I want to do the inverse of multiplication, so I'm going to divide both sides by 4. So I see that x equals 6. So let's check that back out. What's 4 times 6? 24 plus 7 is 31. So correct answer. Let's do one more and then we'll be done. Okay, I want to do the inverse of subtracting. Remember there's no such thing as subtracting, so that's really a negative 3. Okay, so I'm going to add a positive 3 to both sides. Do that first. I'll deal with this in a minute. Okay, so what's a negative 3 plus positive 3? 0. What's 15 plus 3? 18. 6 A equals 18. Let's divide. So that's multiplied. So I'm going to do the inverse or the opposite. Divide both sides by 6. And A equals 3. Okay, so let's go back to our original equation and make sure that's correct. So 6 times 3 is 18, minus 3 is 15, so I'm correct. So remember to do the addition subtraction first, or the stuff that's not directly connected by multiplication first, and then do the multiplication and division, okay? That's kind of the key to this thing. They're kind of fun. It's like solving a puzzle. So have fun with it.